Welcome to the deep dive. Today, we're looking at something that kind of turns solar power thinking on its head,
It really does.
generating electricity from rain, honestly, rain. We've got this white paper digging into it, specifically thinking about Connecticut. So our mission today is really to unpack this. How does it work? Why is it important? And, what are the real pros and cons, especially for a place like Connecticut?
It definitely sounds counterintuitive, doesn't it? Usually rain means, well, less power from your solar panels.
Exactly.
But this idea, it's about adding another layer, capturing the kinetic energy, the energy from the motion of raindrops hitting the panel, right alongside the usual solar cells.
Okay, hang on. How does a raindrop hitting a panel actually make electricity? That part feels a bit futuristic.
Yeah, that's the core tech. It uses something called triboelectric nanogenerators. 10 NAs for short.
10 eggs. Okay.
Think about static electricity, rubbing a balloon on your jumper.
Yes, sure.
That's the triboelectric effect, getting a charge from contact. These tangs are designed to capture that, but on a microscale, when liquid, the raindrop hits the solid panel surface.
Ah, okay. So the impact itself.
Right. It creates this tiny electrical charge, and the 10 system grabs that kinetic energy. So instead of power dropping off when it rains or gets cloudy, you're actually generating some power. It complements the solar.
That is really clever. And the source, it mentioned it's not just about power, right? There are other integrated things going on.
Absolutely. A big one is sustainable water management, basically rainwater harvesting.
Makes sense. You're collecting it anyway.
Exactly. So you channel that rainwater, store it, use it, less reliance on, municipal water. Plus, and this is interesting, the paper notes, you can use that collected water to cool the panels.
Cool the panels. Why?
Well, solar panels actually work less efficiently when they get too hot. So using the rainwater for cooling, especially on hot sunny days, can boost their efficiency. The study mentioned saw up to a 20% increase sometimes.
Wow. Okay. So energy and water. That's a neat combo.
It really is.
So thinking about Connecticut then, lots of gray days, quite a bit of rain. Why is this tech seen as a good fit there?
Well, you nailed the climate aspect. Connecticut is humid continental. It gets decent rainfall, averages around 47 inches a year, and crucially for solar, maybe 180 cloudy days annually.
That many. Yeah, sounds about right.
So traditional solar output really dips on those days. This tech offers a way to generate power precisely when standard solar is, let's say, struggling a bit. Makes it quite appealing for that kind of climate.
Right. So for someone there, the big wins are what? More reliable power year-round and managing water better.
Pretty much. More consistent energy, especially during those frequent cloudy or rainy spells. And yeah, the water harvesting reduces strain on public supplies. The source also touches on resilience. Hurricanes are a concern.
Oh, yeah. Good point.
With proper installation, reinforced materials, secure mounting, they can be designed to handle rough weather. That's critical for coastal areas.
You mentioned that case study before about the cooling. What did that show?
Yeah, it looked at a setup with integrated rainwater collection. It basically proved the concept, showed how using that water for cooling demonstrably boosted the solar panel efficiency, sometimes significantly, like that 20% figure in hot conditions.
And providing water at the same time.
And providing water. It shows it's not just theoretical, there's a tangible value there.
But it can't all be smooth sailing. What are the challenges? The source must mention some hurdles. Durability, cost.
Oh, definitely. Durability in extreme weather, like we said, needs that careful engineering. Cost is a big one, too.
How much are we talking?
Well, paper estimates these 10-gene integrated panels might be around, say, $1.50 per watt. Compare that to standard solar, which can be anywhere from 22 cents to maybe $1.39 per watt currently.
So quite a bit more upfront.
Sure. It is, which means things like subsidies or incentives for advanced renewables would be pretty important to help adoption. And then there's scaling the Tang part itself efficiently for really large projects that's still developing, probably looking at hybrid systems, initially adding Tangs onto standard panels.
Okay, so summing up, it's dual power sun and rain. It boosts efficiency, surprisingly, in both cloudy and hot conditions.
Yep.
Manages water, higher initial cost, but maybe long-term savings.
That's a good summary. And for a place like Connecticut, with that climate profile, the rain, the clouds, it does seem particularly well-suited. It's a move towards more resilient, more integrated environmental solutions for energy and water.
Yep.
Helps meet those sustainability targets.
It's just fascinating, isn't it? Taking something like rain, which we normally think of as, well, bad for solar output, and finding a way to harness it.
It really makes you think about capturing energy from all sorts of everyday things around us.
So here's something to ponder. What if we got really good at this? Harnessing energy not just from sun and wind, but maybe from falling rain, or vibrations, or even small temperature changes all around us. How might that shift our whole relationship with the weather, with our buildings, maybe even with the power grid itself?